So, so first of them is protection of sensitive data via de-identification and data masking. Then will be big data analytics for security. Then an example of big data analytics workflow. So all these steps that are done to the data in order to get some business value out of it. And then big data analytics setup for SAP, which is a system that is used by most large companies and stores critical business data. That system has many modules for different fields. Then current security features in Hadoop environment, future of Hadoop environment security. So Hadoop is the main platform for big data in these days. And then privacy and security from consumers' point of view. So protection of sensitive data via identification. We need to protect sensitive data such as credit card numbers, names, full addresses of the clients, trade secrets, intellectual property of the company. We have used identification and sensitive data masking. In order to perform analytics on top of the bank transactions and credit card data scientists, the people who actually create and work with the data, do need to know the real identity or full addresses of the clients, even they are employees of the bank. So we try to limit the people that need to know the information will know that, but not anybody else. Obviously, they don't need to know the real credit card numbers. On the other hand, bank employees responsible for fraud detection, those people who will call you that something is wrong on your account, or people who make an offers to certain customers, do need to know the real identity, real telephone numbers, addresses, and credit cards. So during the import from the transactional systems, which can be ZOS, mainframe, big system, data is split into small amounts of sensitive data that goes to the separate secure relational database, and the rest of the data goes to the Hadoop-based environment. That's for the big data, for the analytics. So this import procedure also replaces the real client's IDs, so nobody can write down some ID and figure it out, ask somebody from the different department. Is this ID this client or not? And that's important. And credit card numbers are replaced with random numbers. And randomly generated numbers are the same for each entity, each customer, each business entity, must be consistent across all these data sets to enable joins and integration of this data. So pair of matching real and the randomly generated numbers are stored in a secure relational database, and data scientists perform analysis in Hadoop environment, prepare reports, prepare dashboards for the authorized bank employees. Okay, and these dashboards and reports do have access to that secure relational database and replace randomly generated IDs with a real one and with the names of the customers and the real credit card numbers and full addresses. Okay. So big data analytics for the security. So it's not only the source of the problem, but it's a source of the solution. So data-driven information security is extensively used for fraud detection and anomaly-based intrusion detection in banking and other industries. It's nothing new. Although analyzing log files, network packets, and system events for forensic and intrusion detection is also used for many years, those conventional systems, conventional technologies were not adequate to support long-term and large-scale analytics. So essentially they just deleted these logs after 30 days. no space for it. And obviously no way to run analysis on top of it, because if you load a log that is 100 gigabytes big on one machine and try to run some analytics on top of it, it will take you 3 days. So then you think, it's not worth the effort. So the main reason was that retaining and processing large amount of unstructured and noisy data was not economically feasible. The Hadoop and basic big data applications become a part of the security management software because they can help you clean, prepare, and query data in heterogeneous, in an incomplete and noisy formats. So management of large-scale data warehouses was traditionally expensive, and their deployment usually required strong business cases. So Hadoop framework and other big data tools commoditize these deployments of large-scale and reliable clusters. So there's many kinds of security threats. Well, I can talk about one of them. This is a prevention and detection of advanced persistent threats. So advanced persistent attacks are carried for months and sometimes even for years. They can target intellectual property, credit card numbers, trade secrets, clients' information. They can be carried by well-funded criminal gangs, foreign governments, or activist groups. They use techniques like infected email attachments tailored for a specific employee in the company. They prepare booby-trap websites. They mimic official or corporate websites. They search for and utilize security flaws in installed network hardware, OS, firewalls, databases, browsers, and business applications. They can use, as we've seen, stolen certificates and use them to sign software components or application on the App Store as well. So how to prevent and detect these threats? So best cure is the prevention. So it's all the same. It's important to keep and improve current security measures such as firewall settings, user management and privileges, encryption of sensitive data when they are stored and when they are transported. Obviously, SSL for internal and external systems, so not just client-facing, but to have SSL on all the services that are used inside the company itself, even if it's within the region of the firewall of the company. And earlier full security updates of OS and applications, antivirus scans, audit of sensitive data accesses, which is not always done, and protection of mobile devices, notebooks against theft and misuse, and so on. So in these cases, on these devices, the hard drive, the data must be encrypted. So even if the notebook is stolen or the tablet is stolen, the data must be encrypted. So statistical analysis of historical data give us understanding of regular business processes. Because there's a huge amount of data, and we have to know what is the normal thing, what is the situation, what we can expect. So we can see data usages, especially the sensitive data usages, and we can see behavior of employees as well. So application of machine learning algorithms enables us to find outliers, hidden patterns, and correlation and anomalies in the data. We need to utilize supervised and unsupervised machine learning algorithms, and these algorithms on a large data sets can be tuned to see the weak signals, because these persistent threats will not look like a distributed denial attacks, but they will be more like several attempts a day to a specific computer, specific locations, and tries, let's say, if there is some security flaw or some unpatched system on the network. So we can see some trends, emerging trends, and this can be spotted. So this is a practical steps when we have some big data systems. So each of these steps needs to be protected, and that gives us the chance to actually verify the data and make them usable for dashboards and reports. So the connections to the input sources. The input data sources include JDBC access to the backup and production databases, log files that are produced by applications, comma-separated value files and fixed length files, XML files, JSON files, and from the different types of sources like internal, external web services, JMS, MQ, SOAP, REST, and so on. So we do have the initial imports of the data that will take the longest, and then there must be a scheduled updates from all the systems, because we want to have not just a snapshot in past in our big data system, but we want to have this data to be regularly updated every hour, every 4 hours. So we cover already sensitive data masking. Then there is a data quality verification. So input data is verified for duplicate records, missing mandatory fields, corrupted records, and the quality statistics of imported data sets are calculated. And if the quality is beyond certain threshold or something is changed, then alert is triggered and data is moved for manual investigation. We don't want to lose any transactions. So then next steps are triggered. So duplicate and corrupted records are eliminated. This can appear in any stage of the ETL process and can be a result of duplicate imports of the same report or the same report from multiple sources as well. Then unused fields are removed, and then is another thing, which is a conversion of the data fields into the common format. So when we have different systems, different databases, different applications, those timestamps, dates, currency fields do have various formats. Yeah? So we choose common formats for all these fields at this stage. We also perform unit conversions, we transformation of multiple fields into a single field. So sometimes we have a name in three fields. You have to put it in a single field and so on. Then we have joining data sets for different sources on common key fields. And then the data is stored in a Hive. So it's not directly in HDFS, but it's stored in a Hive, and it looks like so we can access it through SQL. So data import, compression, partitioning, and clustering. So all these things essentially improve the performance of the queries, reduce the size of the stored data. So again, many of those fields are highly compressible, and binary formats can improve the performance. So then we can go and look for the practical big data analytics setup for SAP. So as you see this picture, there is all these different components that are used in a big data. I can go through it. So SAP system has many modules, SAP CRM, SAP FI, many more. SAP uses Oracle database that works well for transactional processing. Our clients use warehousing and analytics solutions on top of the Oracle database. These solutions were not very flexible, they were expensive, and so they decided to implement it in a Hadoop. And then, so the solution must enable a capable of a combination of SAP data with other data sources in the company, must reduce license costs for the databases, data warehouses, ETL tools, analytic and reporting tools. Must enable a faster deployment and easier modification of the reports, because that was the highest concern from the top level of the company, because they want to have reports and they want to have them quick, and they don't want to wait half a year to make changes in a star model or cube models. And another thing is we must be able to apply many machine learning models for the same data in reasonable time. So then we expect a faster processing of complex table joins and queries, because they were quite slow when we had a large amount of tables in a Oracle database. Then faster refresh of SAP data and other systems. So instead of once a day, it was every 4 hours. Then we need to run analytics on non-aggregated and full data sets. So there's another requirement for it. Obviously, the system utilizes MapReduce framework for ETL and SQL queries and machine learning algorithms. So another thing was that the system must be able to capture historical events from SAP and utilize the from and to dates as well. So we need to know the complete history of clients and all contracts, for example.
Ladislav, we've only a couple of minutes.
How many?
2 minutes.
2 minutes. Okay, so that's a lots of things. So if you have some questions about this schema, yeah, it's also technical things. But the thing is, it's a good to know it in terms of making a decisions and see a bit of the complexity of it. But overall, this solution enables you to run the queries and run analytics that way that were not possible before, because you would have to make a special database which has like a star model, and if you want to have a report that is a little bit different, then you have to make changes in the star model, which is very strict referential model. This solution lets you to query the data from different angles without making changes of the data themselves. So secure and security features in a Hadoop environment. So if somebody claims that Hadoop is not secure, it is secure, but there are some limitations. Obviously, it enables authentication, service level authorization, data confidentiality, and authentication of the web console. So authentication, users using Hadoop in secure mode needs to authenticate via Kerberos, and the service level authorization requires clients connecting to particular Hadoop service to have necessary configured permissions and authorization to access it. Data confidentiality, so data transfer between Hadoop services and clients are encrypted. Okay. So do you have some questions?
Well, thank you.
You're welcome.